Hi guys, my name is Nick and I'm back with another video, and today I'm going to show you how to make this tiny little rover. But before we begin with the tutorial, I'll quickly just demonstrate it so you can see if you even would like to make something like this. So we just first connect. It is a Bluetooth based, but you could easily change it to remote control or something else to whatever you'd like. But anyways, so there are the 4 directions, so you can go backwards, forwards, left, and right. And as you can see, it's actually pretty darn fast for the tiny little motors it has. And then, on top of that, it also has 2 servos, which I originally used for mounting a tiny FPV camera on there, but you can do whatever you'd like with those. So you can just use these 2 sliders, and then this one will make it go up and down, and then the other one you won't be able to see it because there's no arm, but it will rotate this servo arm left and right. But as I said, you can use that for whatever purpose you have in mind. Anyways, now that we have the demonstration, and I hope you'll be interested in making one of these, now let's move on to the tutorial. So for this project, I used 2 tiny little geared DC motors that are pretty standard, and you can find them anywhere on the internet, and it's really not specific, so you can just use what you have. It does not matter. Now, the way I controlled these motors is I used servo H bridges, and these are just standard H bridges found in any 9-gram servo. And the way I repurposed mine was I basically cut the leads from the H bridge, which would normally go to the servo motor, and then I resoldered them to go over to the DC motor. Now the second thing I did, and this is the only other thing you'll need to do, is I cut all of the potentiometer leads and I replaced them with 2K ohm resistors. And it basically went, one of them goes from ground over to where the potentiometer output normally should be, and then the other one goes from 5 volts over to where the potentiometer should be, and those two resistor leads should meet and then be soldered on to that little pad. Now you could also just put a bit of glue in the servo to lock it right in the middle, but it's one less thing to worry about, just because there could be a slight chance that the servo or the glue breaks, and then the servo or the potentiometer starts turning, and then it stops working all of a sudden, and you won't know why. So it's just one less thing to worry about. And then these are just the input 5 volts ground, just to control the motor for forwards, backwards, and speeds and stuff. Anyways, now let's move on to the schematics. Okay, so for this project, I'll be using a ATtiny84, 2 of those tiny motors, 2 tiny servos, and an HC06 Bluetooth module. You can use a Bluetooth module of your choice. This is just what I happen to have. So, obviously the 5 volts will route all together, and that goes to pin 1 on the ATtiny84. And then same with the grounds. Grounds go to all the other grounds in all the parts, and that also goes to pin 14. Now, the motors, in this case the left motor, will be going to pin 8, and the right motor will be going to pin 7. Now, if that's backwards for you, you can always just reverse the pin values in the code. Now for the Bluetooth module, since the HC06 it connects serially with the chip, we basically do the software serial library, so we need to dedicate 2 pins to that. In this case, the transmit pin, which will then feed into the receive pin on the module, is pin 10, and then the receive pin on the chip, which will be pin 11, that'll take the information from the transmit pin on the Bluetooth module. And then finally, the little servos, they go, either one, as I said, you might have to reverse them. It all depends. So in this case, let's just say the up and down servo goes to 5, and the left and right goes to 6. So that is the basic wiring of how it's supposed to be all put together. So now we will move on to the code. Okay, so here is the code for the little rover. So first of all, we want to include the software serial library so we can communicate with the HC06 Bluetooth module. After that, we want to define all of the variables for the motors and the servos, and we give them their respective pin values. Now the test value, variable, it's basically a placeholder for the incoming Bluetooth value, and you'll see where it's used later. The num value, that's basically just a direction in which the robot is going. Now these 4 variables right here are used for controlling the up-down and the left-right servos. And as you can see, we just set them to 1500 because that's going to be the center position, and that's always a good place to start out. Now the reason why there's 2 sets of these variables is that we have the current variable and an old variable, and you'll see why that's used later. And finally, we have a software serial variable named Bluetooth, and this is what we will use to connect with the Bluetooth module. And we just give it our transmit and our receive pins on the AT-Tiny. In the setup, we first want to set our motors and our servos to output, and we'll use that with these set of pin mode functions. Now, before we go any further, we want to center our up-down servo, our left-right servo, and we want to make sure that the left and right motors are stationary. Now, since we don't have our own servo right function, since the library does not work on the AT-Tiny, we'll just have to do it ourselves. So in order to do that, we first want to write to the servo pins high, then we want to delay in microseconds. In this case, we're going to do 1500 because we want it centered, because the value will go from 1000 to 2000. Then we want to write low, and then we want to delay for what you would normally do as 20 milliseconds, but to offset the little delay here, we just take it down to 19. And that's how you send servo pulse without the servo library. Or at least that's one way you can do it. Now, the same thing applies for stopping the motors. Since, as I said before, they take the H bridges, they'll also take the same servo signals that these servos up here do. So all you need to do is change out the variable names to the left and right motor, and you are good to go. Finally, we want to begin the connection with the HC06, and we'll do that with this line right here. Okay, so in the loop, we first want to check if there's actually a new value from the Bluetooth module, using this line right here. If so, then we want to set our test value to whatever that new value is. Then right away, after we get that value, we want to rewrite it back to the phone. Now you wouldn't normally use this, but I just use this for the debugging phase, just so I know, or I knew what values were going across and how they were being parsed, just to make sure nothing was being changed throughout the transfer. Now these if statements are used primarily to determine whether, or not primarily, they're only used to determine whether it's an up-down signal, a left-right signal, or a direction signal. So basically, it'll look if that value is greater than 25 or less than 125, and that means it's an up-down servo value, which means that we want to set the up-down position variable to whatever that is. Now since you can only send, or I was only able to send a 1-byte number for simplicity's sake, I basically had to package it into a smaller form. So this little math equation right here just kind of decompresses it into a pulse that the servo can read. And the same goes for this one, except it checks whether the value is greater than 125 and less than 225. And then it does the same depacking like before. And finally, if it's less than 25, I'll note that it's a directional value, because the directional values only go from 1, it's a 0, 2, 3, 4, and 5. And so we'll just set the num variable, which is the direction, to whatever that value is. So right here in these if statements, we basically just check whatever that num value is, and in this case, if it's 0, we just want to stop the robot. So we just write what we had at the very top, which is with the 1500 microseconds. Now let's say we want to go forward instead of stationary. Well, in that case, the Bluetooth, the phone would send a 2 as the value. And if we receive that, then we're going to want to go forward. So to do this, we want to do pretty much the same thing, except normally you could still leave the servo right in these two blocks, but because one of the servos was running a bit faster than the other, I had to do it in two separate things just to account for the speed difference. Anyways, so for the right servo, we set it full speed forward, and for the left servo, we want to slow it down a bit, because as I said before, it was going a bit faster than the right servo. And the same applies for all the other num values that you could receive. And it's just different values that you send to the servos for the different movement. Now down here, we have our final bit of code, and this is just to control the up, down, and the left, right servos. So basically, all it checks for is if the new up, down value, if it's different than the old one, then we want to write to that servo the new up, down value. And then we want to set the old value back to the new one. And the same goes for the left, right servo. So there you have it. That's all you really need for the code. And now let's move on to the phone section. Okay, so here is a quick overview on how to make the app. So, first of all, as you can see, I made it with the MIT App Inventor just because it's really simple and it works really, really well. Anyways, what you'll need is a list picker, a label, 4 buttons, 2 sliders, and 2 extra labels just for kind of aesthetics and labeling what the sliders do. You also need some, what are they called, like aligners and spaces, just so everything looks neat, but that's user preference right there. Basically, all of this stuff you can leave standard, or you don't need to change anything, except for the sliders, where you need to make sure that the max value is 2000 and the minimum value is 1000, just so, as I said before, that's how the servos get their pulses, or the values that they will take. Anyways, now we can move on to the blocks. And so the first block we want to look at is before someone chooses what Bluetooth module to connect to, or what Bluetooth device, what this list picker will be doing, or what the program will be doing, it will basically just keep refreshing the list with all the new Bluetooth clients out there that you can connect to. And then once you click on the list picker, it'll bring down a nice list of all the things you can connect to. Now, once you've chosen something, it's going to check whether it can connect to that Bluetooth device, and then it'll be connected, and you'll be all good to start sending commands. So, the first set of things I want to just look at quickly are the buttons. Now, they're very self-explanatory and very easy, so I'll just quickly go over them anyways. So, basically, what you have is when it gets pushed down, it'll send a number. In this case, it's a 3. And then after that, it'll set the label to whatever that button or whatever that Bluetooth receives. Because remember, the Arduino is going to be sending back a value as well. So this will set the label to whatever that value was. Then when you release the button, or what they call a touch up, then it'll send a 0, which for this program is basically stopping the robot. And then, yet again, it will check for the number sent back by the Arduino. And this basically goes for all the other buttons, except instead of a 3, it's a 2 or a 4 or something else. But whenever they touch up, they will always send a 0. Now you can always change this to whatever you'd like, but in this case it's going to be a 0. And now the final thing on this program is the slider. So basically all we need is when the slider position changed, with this little block right here, all we want to do is get the thumb position and send it over to the Arduino. Unfortunately, a 1-byte number can't hold more than 255. So we'll have to do that little compression thing that I was talking about, so that you can fit the 2000 to 1000 into a 225 value. In this case, it goes from about 125 to 225, just because we have two values that are being sent. So in this case, for the up-down servo, we're basically going to get the thumb position, and it's basically the exact opposite of what the Arduino function was. So this will compress it, and then the other one does the exact opposite to decompress it. So it divides it by 10, subtracts 75, and then it sends it as a 1-byte number. And the same thing happens with slider 2, except instead it divides it by 10 and adds 25. And as we can see on the Arduino program, on the decompression, in this side, it adds 75 and multiplies by 10, and for the left-right, it subtracts 25 and multiplies by 10. So it's the exact opposite, and it works really well. Anyways, that is it for the code for the Arduino and the phone. I'm going to say that's pretty much all you're going to need to know to make this little rover. So I hope you enjoy making it. I wish you good luck, and I'll see you next time. Bye!